Hello everyone. In the last couple of lectures, we have discussed about how to write algorithms using pseudocodes. Today we will see how to draw flowcharts. Today's lesson, chapter 3, creating flowcharts. Here I am going to explain about what is a flowchart, what are the symbols that we can use to draw the flowcharts, the general rules for designing flowcharts, some examples, and eventually the advantages and the disadvantages of using flowcharts. Okay, let's start. What is a flowchart? A flowchart is a schematic, or we can say diagrammatic, using special symbols to replace the actual pictures, to representation of an algorithm or a process. Flowchart is a visual representation of the sequence of the steps and decisions needed to perform a process. It means graphical way of an algorithm. Flowcharts describe the operations which are required to solve a given problem. And flowcharts are helpful to understand complicated programming logics and to explain those logics to others. If you can remember, I have mentioned in the very first lecture that we can represent algorithms using pseudocodes and flowcharts. Now you know how to write the pseudocodes. Actually, flowcharts are easier than the pseudocodes for understanding. At the first sight, we can understand it rather than the pseudocodes. A flowchart has different states. To represent each state, we are using different symbols. Let's see what are those. First one is a rounded rectangle. We are calling it as terminal symbol. Starting and ending is required of all flowcharts, so we are using this symbol to represent the starting and the ending of the flowchart. In starting position, we have to write the word start in the middle of the symbol, and at the end we need to write the word end in the inside of the symbol. And also we can use oval shape for this instead of the rounded rectangle. It's your choice. I am normally using the rounded rectangle. Then the next symbol is rectangle. We are calling it as process symbol, and it is represent an action or a process in an algorithm. Process involves the action or the verb part of the flowchart, simply what we are doing in the verb. For example, add 1 or turn the lights off or rotate the part, like that. One action we need to write inside of this rectangle. Then the third symbol is a parallelogram. We are calling it as input or output symbol. Many times in program, user needs to input some data or some values, or program going to output something to user or other computer. So we are using this symbol to indicate the manual input to output operation when that needed. For example, type in the balance, check the balance, or print number, like that. One input to output operation we can write in the inside of the parallelogram. Then the next symbol is rhombus, or we can say the shape diamond. We are calling it as decision symbol. It represents a question that can be answered in the binary format, simply the yes/no questions. Flowcharts will turn into two directions based on this question. One path is for what happens it is true, and the other path for what is happens it is false. We can use this for represent the selection and repetition structures with the other symbols. For example, is this the number larger than 10? Has count been reached? Like that. One question we can write in the inside of the diamond shape. Then another important symbol is arrow, and also we can call it as flow line. This indicates the flow direction of logics and the data flows. It is keeping the track of the direction of the flow. Arrows are drawn from the output of one block to the input of another block. Only the one arrow can represent the outputs, and the multiple arrows may represent the inputs. The next symbol is a rectangle with two small parts divided in the inside. we calling it as predefined process symbol. This is not very common as the earlier symbols. This symbol is represent a group of statements performing one processing task. It means that reference another process within this process. For example, we can get a method inside this process. Finally, a circle, or we can call it as the connector. Actually, this is a small circle than the other symbols. We are using this to join different flows. For example, there is no enough space to draw the whole flowchart in one paper. We can use two papers and the connector symbol in both ends that connect in the flowchart. Those are the main parts we are normally using to draw a flowchart. There are many other symbols to indicate various purposes in flowcharts, but mainly most important basic symbols are these. General rules for designing flowcharts. The first one is all states in a flowchart are connected using arrows. We cannot use lines to join the states, only the arrows we have to use. And the second one is there should be only one starting state in a flowchart. And as I earlier mentioned, starting state should be represented using a terminal symbol, rounded rectangle, and you should write the word start inside of that. And the third one is there should be at least one ending state in a flowchart. There can be 2 or 3 ending points according to the decisions and the output of the required. But there must be at least one, and the ending state should also be represented using a terminal symbol, rounded rectangle, and you should write the word end inside of that. Then the next one is except decision symbols, all other symbols can only have one exit or one output point on their bottom side. Decision symbols can have 2 exit points. These exit points can be either in the 2 sides of the diamond or one exit point in the bottom and one in a side. And next point is generally flowcharts flow from top to bottom. Also we can draw bottom to top flowcharts only if it does not have more than 3 symbols. Normally we are using top to bottom flow. Then the next important point is if we break our flowchart into multiple parts, we have to connect these parts using a connector symbol, a small circle. You have to put a connector in the both ends that flowchart connects, and if you have to put more connector points, you have to label it from numbers or characters, and you have to give the same number for the two ends that connects together. And there are special places that we can break our flowcharts. We cannot break it in the every places. The first one is if our flowchart is extending from one page to another. It means a flowchart is very big and it goes for 2 pages. We have to connect them using a connecting symbol in the first page end and the second page beginning of the flowchart. And the second one is when the upward flowchart, it means bottom to top flow has more than 3 symbols, because earlier also I mentioned that we can only draw bottom to top flowcharts with only 3 symbols. So if we had to put more than 3, we have to draw it separately and connect by the connector symbol. And the last one is when we need to expand the flow from the bottom of the page to the top of the same page. It means when we had to divide a long flowchart to 2 parts and place in the same page. So we have to put a connector to the bottom of the page which breaks the breakpoint, and the top of the page which continues the flowchart. Now we will draw a sample flowchart. In here we are going to design a top-down flowchart for a program which takes the radius value as the user input and calculate the area of the circle and display the output to the user. So the process is input the radius, then calculate the area and output the results. First of all, we need to start the drawing of the flowchart with the start terminal symbol. You can see the symbolic representation in the slide. The word start in the inside of the rounded rectangle. Normally, we are writing a description inside of the every symbol. Then we need to take the input from the user, the value for radius. So we use input output symbol, the parallelogram, and it connects to the start symbol. For connecting, we are using the flow line, or we can say an arrow. And now you can see in the diagram in the slide, arrow is starting from the bottom of the start symbol and connects to the input symbol. Here I have get the input as read R, means read or get the radius from the user. As the next step of our program or algorithm, we need to calculate the area of the circle. This is a processing stage which will happen inside the CPU of the computer, because we need to do a calculation. To represent this, we are using a process symbol. You can see in the slide, again we are using the arrow to connect the process symbol to the part of the flowchart that we built until now. Inside of the process symbol, inside of the rectangle, we have to write the equation that gives the area of the circle. Area equals 3.14 asterisk r power by 2. It will calculate the area of the circle according to the r value and will store it in the variable area. Then after that, our program needs to print the area that we have calculated. So this is the output. We need to use the input output symbol for represent that. Again we are using an arrow to downward from the process symbol to the input output symbol, and inside of the parallelogram we need to write print area for displaying the output. At last we need to terminate the flow using the terminal symbol with the inside of that. It also have to connect to the parallelogram by an arrow. So first we start, then read radius r, then calculate the area by area equal 3.14 asterisk r power by 2, then prints the area and end. Start and end with the terminal symbol, rounded rectangles, and the input read r and the output print area with the input output symbol parallelogram, and the process is with the process symbol rectangle. This is very simple example. You can see it very clear and easy to understand. Use of the decision symbol. Decision symbol is used in the places where the program involves in taking decisions. Outcome is either yes or no in here. Flowchart will turn into two directions based on the answer. For example, we can get that displaying the largest number among two numbers. As you can see in the slide, if A is greater than B, if that is true, we can print A, otherwise we can print B. We can use decision symbol for if A greater than B and two arrows in two sides. If it is true, in the one side arrow and input output symbol prints A. If it is false, other side arrow and in that side input output symbol print B. If you can remember, this is a selection structure. We can use decision symbol to indicate that the selection or repetition structures with the help of the other symbols. Now we will see how to draw a flowchart for the above scenario with the user inputs. A program which finds the largest number from the user entered two values. In here we have to display the maximum number among the given two numbers by the user. First we need to start with the terminal symbol, start with the rounded rectangle. Then we need to get the two inputs from the user, read A, B inside of a parallelogram. Then the decision inside of the diamond shape if A is greater than B. If it is true, we need to print A, otherwise if it is false we need to print B, and print A and print B are both outputs, so we have to use the parallelogram. Then end the flowchart by the connecting both ends with the end terminal symbol. We need to place arrows in every flow, don't use just lines. And another important thing is we need to put true or false, or otherwise we can use yes or no on the two arrows that go in from the decision symbol, because according to that only we have to decide what we have to do. I think you all have got an idea now. The above example for if-else, or we can say the selection structure. Now we will see how to use the decision symbol for repetition structure for the while loop. In here we want to draw a flowchart for print the numbers from 0 to 9. As the first step we want to start the flowchart by the start terminal symbol. Then in the while loop, what we will do in the first? The initialization. So in here we want to start it from 0 because we have to print the numbers from 0. So the initialization condition is n is equal to 0. We can write it in the inside of the process symbol. And in here I have got the number that we want to print as the variable n. Then we want to give the termination condition in while loop in here decision symbol. We have to check the numbers until 9. So in the decision, if the n is less than 10, if it is yes, we have to print the n, the number as the output, and again we have to step up the condition and check the number. For that we can use a process symbol, and inside of that we can increase the number by 1, n is equal to n plus 1. And again we have to check the condition. So automatically the yes flow makes a loop. If it is no, then we have to end the process. Now we will check this. First start, then we initialize that as n is equal to 0. So 0 is less than 10, then it is yes, then print 0, and then in here 0 plus 1, 1. Now n is 1. Again check the condition, 1 is less than 10, then again yes, print 1, and again the step up condition, 1 plus 1, 2, 2 is less than 10, then again print. Like that until 9 it will print. When it prints the 9, then n equal n plus 1, it means 9 equal n equal 9 plus 1, 10. Then 10 is greater than 10 is not less than 10, so it is no, and end the process. Okay, I think you have got an idea how to draw a flowchart for every scenario, selection and repetition. The advantages of using flowcharts. First one is effective communication. Using the flowcharts, we can easily describe our programming logics rather than using just plain English. This is an effective way rather than the pseudocodes because this is clear, understandable quickly, and eye-catching. And the second one is effective analysis. With the help of the flowchart, problem can be analyzed in more effective way. Therefore, it reduces the cost and the wastage of the time. And the third one is effective coding. Because of the flowcharts act as a guide or a blueprint during the system analysis and program development phase. The fourth one is easy debugging and efficient testing. The flowchart helps in debugging and testing process. And the fifth one is proper documentation. Program flowcharts serve as a good program documentation which is needed for various purposes and making things more efficient. And the last one is efficient program maintenance. The maintenance of operating program becomes easy with the help of the flowchart. It helps the programmers to put effort more effectively on that part. There are advantages as well as the disadvantages in here using flowcharts. The first one is complex logic. Sometimes program logic is quite complicated. In that case, flowchart becomes complex and clumsy. This will become a pain for the user, resulting in a waste of time and money trying to correct the program. And the second disadvantage is difficulty in modifications. If alterations are required, the flowchart may require redrawing completely. This will usually waste the valuable time. So those are the advantages and the disadvantages of using flowcharts. Okay, I think you all have got an idea what is a flowchart and how to design that and the advantages and disadvantages of it. I have uploaded a worksheet with some questions to design the flowcharts. Try to do that. And also I have uploaded the PDF version of the slides also. Find that. If you have any question, you can email me. I have given my email address in the first slide. And thank you.